so learning about polyatomic ions today. A polyatomic ion is an ion that has bonded together to have a net charge for the whole group. All right, so again, ions have charge. Typically, there's a series of polyatomic ions. It'll be like a little family, right? They'll contain where they contain oxygen. The one that has the most oxygen will end in 8. The one with the least will end in ite. Right, so for example, the nitrogen family, right? NO2 is nitrite because it has fewer oxygen. NO3 is nitrate because it has the most oxygens. Same thing with sulfate, has more oxygens than sulfite. All right, so you don't have to memorize polyatomic ions. You just have to know how to use them. There is a list. All right, if you go to periodic tables formula sheets on the home page and then click on the formula sheet. Here's your periodic table and then keep scrolling. Here we go. Here is the list of polyatomic ions. All right, right here. All right, so let's do this first example. All right, so we have Na2SO4. All right, it's the same rules as normal. So first thing I'm going to do is I'm going to look for the type. All right, so that's not what I want. So looking at your type 1, Na is simple. So we're just going to name the first one, name the second one. So Na is sodium. So I'm going to name Na as sodium. Then I'm going to look on my polyatomic ion sheet for SO4. I'm not going to do this every time, but I'll look. SO4 is right here. So that is sulfate. All right, so it is sodium sulfate. All right. So now I'm going to look, do the second one. All right, Fe is a Roman numeral ionic, which makes this a little more complicated. So I'm going to have to do my algebra. I'm going to call Fe's charge X because I don't know what it is, minus the charge of NO3. If you look on your polyatomic ion sheet, it has just a little negative up there, so that means it's -1. So -1 times, there are 3 of these. Remember, we set this equal to 0, so x minus 3 equals 0. So add 3, x equals 3. All right, so Fe is iron, charge is 3, and NO3 is nitrate. All right, so same rules as your normal ionics. All right, all polyatomic ions are only ever going to be used in ionic compounds. All right, so let's look at these ones. Now remember, first thing you do is find the type. All right, type 2 is name cation. 3 is name the polyatomic ion. All right, so CO is a Roman numeral ionic. So I'm going to say CO's charge is X minus the charge of ClO3 is -1. All right, so 1 times there's 2 of them equals 0. So X minus 2 equals 0. So X equals 2. CO is cobalt. Parentheses 2, ClO3 is chlorate. Okay, now let's look at the next one. Li is a simple ionic, so I just have to name the cation. Li is lithium, and then I look at my polyatomic ion sheet for OH. That is hydroxide. All right, I know something's a polyatomic ion if it has two capitals next to each other, right? So we're not going to name this like oxygen and then hydrogen. But you see two capitals next to each other, you're going to find that polyatomic ion on your sheet. All right, PD is a Roman numeral ionic. I'm going to call its charge X. SO4's charge is -2, times, there's two of them, equals 0. So X minus 4 equals 0. So X equals 4. PD is palladium. Charge is 4. SO4 is sulfate. There you go. Make sure you're following along with your polyatomic ion sheet. You do not have to memorize these. It is you do need to know how to find their charge, though. All right, so now let's look at the opposite, how to get the formula. All right, so we're going to start step 1, write the symbols. All right, so beryllium is Be, and then our polyatomic, hypochlorite, if you look on your polyatomic ion list, is ClO. Step 2 is the charges, beryllium. I will show you on the periodic table. Remember, charges, right? +1, +2, skip these, +3, plus or minus 4, -3, -2, -1, and 0. So since beryllium is in the second group, it has a +2 charge. All right, so it has a +2 charge. ClO has a -1 charge. All right, we're going to switch them. All right, so the 2 goes down here, the 1 goes down here. So Be, we don't write a 1. Remember, we don't write negatives or positives. And then ClO, you need to write the 2, but you don't want to just say that you have 2 oxygens. You want to say you have 2 of the whole polyatomic ion. So we're going to put it in parentheses. All right, so we don't need to reduce the numbers, but our polyatomic ion is in parentheses. All right, so you guys try these ones and see how you do. All right, so remember step 1 is symbol, step 2 is charge, step 3 is to switch them, and step 4 is reduce / parentheses. All right, so lithium is Li, sulfite is SO3. Lithium has a +1 charge, sulfite has a -2 charge. All right, so step 3, switch them. The 2 and the 1 swap. So it's going to be Li2SO3. All right, I cannot change this number right here. That is how many oxygens it has, not how many sulfites there are. All right, so there would be a 1 on the outside, but we don't write a 1, so therefore we also don't need parentheses. All right, let's try the next one. So symbols, tin is Sn, phosphate is PO4. Step 2, charges. Charge for tin is right here, +2. Charge for phosphate is -3. All right, step 3, switch those. The 3 and the 2 swap. So it becomes SN3, PO, I need to keep that 4, parentheses 2. All right, be very, very careful that you don't go SN3PO2. A lot of people try to change this number, but you can't do that. All right, 4 and then parentheses, the 2 goes on the outside. All right, let's try the last one. Symbol for lead is Pb. Symbol for hydroxide is OH. Charge for lead is +2. For hydroxide, -1. Step 3, switch them. So Pb, don't need to write a 1. OH, parentheses 2. All right. So that is it.